Hi, I'm Dan.
Hi, I'm Alex, and this is our Bearkite project. Our primary focus in building this kite is to keep everything lightweight, but also strong.
For the second part of the experiment, we'll be testing the stability and control of the kite with 5 different tail designs.
This is a picture of all of our supplies. We use 1/8 inch dowel rods for supports, broadcloth, epoxy as adhesive, nylon string, and 1/2 inch wide ribbon. The kite is 40 inches wide and 14.5 inches tall.
The ribbon attaches at the inside bottom of the kite. In order for the kite to keep a bend, we attach the string at each end of the crossbar with duct tape. As you can see, the keel, which is a right triangle, is a separate piece from the kite with dimensions 7 by 15 inches. We decided to do our flight testing at Sawyer Point down by the river. We knew that there'd be a lot of wind there because it was close to the water, and we knew it would be very open because there's no buildings and very few trees around, and those steps were a really big help to us because we could fly over the steps. And in this clip you can just see how windy it was for us.
Our first tail was a single short tail. It was very hard to control and very unstable.
Our second flight test was 2 short tails tied next to each other. It flew okay. It wasn't very stable. It was a little bit harder to control. As you can see, I had to struggle really hard to keep it straight and in the air. And actually you can see even here better how hard it was to keep straight. The more wind there was, the harder it was to stay stable and straight up in the air, and it kept crashing like that.
In this clip we used 3 short tails. While it had decent stability, it didn't have much control, and when the wind picked up, we lost most of the control. Here we have 2 ribbons tied together on the kite. We had a lot of control and a lot of stability. When the wind picked up, it seemed to be having fun.
Our final test was to tie all 3 short ribbons together to make one long tail. This was incredibly stable, and we had a lot of control. The majority of our tests were using this one because it stayed in the air for so long that we were able to continue testing with it. As you can see from all of these clips, I was able to keep it in the air for a very long time. Even when the wind started getting a little weaker, I was able to keep it by pulling it up a little bit. It stayed in the air for a very long time. In the end, our kite turned out to be successful in flight. The design worked well in wind speeds around 8 miles an hour and even better in faster winds. Even though the epoxy didn't look very good when dry, the durability proved to be beneficial when the kite struck the ground. As for the tails, our best results were with the single long tail. Its flight was the longest and took the most line. It was by far the most stable and easiest to control.
We think that the weight of the tail allowed for the best angle to catch the wind, resulting in a better flight. The other 2 tails that had a decent flight were the 2 long and the 3 short. We've concluded that the single long tail flies better than the multiple short ones. For future testing, a good idea would be to test multiple long tails.